In a previous video, we learned that what makes a metal is that the material consists mostly of metal atoms, and the atoms are metallically bonded together. A polymer, on the other hand, is organic and consists of long-chain molecules. And ceramics are inorganic, made up of metal and nonmetal atoms, which are bonded together with a mixed ionic and covalent bond. But why do I keep talking about a mixed ionic and covalent bond? You probably remember learning about ionic bonds and covalent bonds in chemistry and are thinking, well, is it ionic or is it covalent? It can't be both. I promise, we will learn more about this later. But the short of it is, yes, it is both. In ceramics, the bond can lean more towards ionic or more towards covalent, but it is usually a bit of both. In this video, we are going to talk about selecting materials for a particular design or product. One of the first things you want to consider when selecting material for a product that you are going to design is what is that product meant to do, or how is it supposed to function? Material properties are key to the success or failure of that product. If you understand how a material behaves, you have a much better chance of choosing the right material for the job. So let's spend a little more time talking about material properties. Look at the collection of objects on the screen. Which ones are made of metal? The wrench is made of metal. The paperclip is made of metal. The radiator and the penny. Because metal atoms are metallically bonded, metal has some very cool properties. We've talked about some of these properties in a previous video. Here's a list of some properties. What properties would you associate with metals? Would you consider metals to be strong or weak? Strong. A wrench has to be strong or it wouldn't work very well. How about brittle or tough? Tough. How many of you in a pinch have used a wrench as a hammer? If you can't tell, I'm raising my hand right now. Is a metal hard or ductile? This one may be a bit trickier. Metals can be made harder through heat treatment and strengthening processes, but in their pure form, they are generally ductile materials. Imagine yourself bending the paperclip. It bends. It doesn't break. Metals have an extraordinary ability to plastically deform before they fracture. Are metals conductors or insulators? Conductors. The radiator wouldn't work very well if it wasn't able to conduct heat into the room. Lastly, in general, do you think metals have a low or high melting temperature? In this case, there are a few exceptions, but for the most part, structural metals have high melting temperatures. Mercury, for example, is one metal that is liquid at room temperature. Material properties are an important consideration when selecting materials. Can you imagine a wrench made from plastic? We need a wrench that is strong and tough. A plastic wrench wouldn't work very well. And do you think a radiator would work if it was made out of ceramic? Look at the collection of objects on the screen. Which ones are made of polymer? Yeah, the oven mitt, the spoon, the tongue depressors, and the rubber bands. Based on what you know about polymers, plastics, and rubbers, what type of properties do you associate with them? Are polymers relatively strong or weak? Relative to metals, they are weak. You would have a much better chance of breaking the plastic spoon than you would a metal spoon. Are plastics or polymers brittle or tough? Well, that's a tricky one. You wouldn't consider the silicone oven mitt to be brittle or the rubber bands, but you could break the spoon and the tongue depressor. So we will leave that answer as it really depends on the type of polymer. Are polymers hard or ductile? Again, this one really depends on the polymer. I would say in general, they are not hard relative to metals and ceramics, but if you look at a polymer like epoxy, that can set up quite hard. Are polymers conductors or insulators? They are insulators. The oven mitt wouldn't be very useful if it didn't insulate your hand from the heat of the pan. Do polymers generally have low or high melting temperatures? Many thermoplastics, which is a type of polymer, have low melting temperatures, which makes them easily recyclable. But elastomers and thermosetting polymers, which are other types of polymers, have higher melting temperatures and are harder to recycle. What do you think would happen if the spoon was made from ceramic? It would function just fine. It would probably even feel good. But one false move and a drop on the kitchen floor, and that spoon is no longer. And no, I'm not speaking from personal experience. I don't drop things. No, not me. All right, look once more. Which ones are made of ceramic? We have the glass insulator, we have the brick, the sandpaper, and the knife. Based on what you know about the objects shown and ceramics in general, what type of properties do you associate with them? Are ceramics strong or weak? And are they brittle or tough? In general, ceramics are both strong and brittle. I know you are thinking to yourself, but I can easily break the glass and the bricks. But you can also easily bend metal. Think about the paper clip. Just because metal doesn't break when you bend it doesn't mean it's stronger than ceramic. It really depends on what definition you are talking about. The difference between metal and ceramic is that metal deforms before it breaks, and ceramics don't. They just break. But a lot of ceramics take more force to break than metals do to bend. So what does that mean? It means that generally ceramics are strong and brittle, whereas metals are generally considered strong and tough. Of course, there are always exceptions. Are ceramics hard or ductile? Ceramics are hard and make ideal abrasives, like in the sandpaper, and cutting edges, like the knife. Are ceramics conductors or insulators? Insulators. They are both electrical and thermal insulators. Do you think ceramics have low or high melting temperatures? They have high melting temperatures. In fact, ceramics are often used in the construction of ovens and crucibles for melting metals. Can you imagine a metal brick? It would be strong, but it wouldn't insulate your house very well, and it would be way too heavy. So why have I spent so much time talking about material properties when this is supposed to be a video on material selection? Like I said, material properties are key. You need to understand how a material behaves in order to be able to pick the right material for your particular design or product. But are material properties the only thing we need to consider when we choose materials? No, there are many other things to consider. In part 2, we will take a look at these factors.